In this exercise, we need to show that the given function, for example in A we are given this function, we are supposed to show that it is a solution to the differential equation. So here, no need to solve the differential equation yourself. It is enough to just substitute the function y and its derivative. We should differentiate the given function and substitute the function and its derivative to the equation and see that it is true. Let's start. In A, our function is y equal to x to power 3 divided by 3. The derivative of y would be 3x squared divided by 3. That is just x squared. Well, we can read from here that the derivative of y is equal to x squared. So our equation is okay. In B, our function was y equal to 2 times e to power minus x plus x minus 1. Well, the derivative is 2 times e to power minus x times the derivative of the inner function, which is minus 1. That's the first term. Derivative of x is 1 and derivative of minus 1 is 0. So we can write the derivative as minus 2 times e to power minus x plus 1. Now we know what our function is and what the derivative is, and we can substitute them both into the equation. We would get that derivative of y should be equal to x minus y. Let's see if this is true. Well, in the right hand side we have x minus x. The x's will cancel out. Then we have a minus sign here. It changed the first term into minus 2 times e to power minus x, and then we get plus 1. Okay, we see that the equation is okay. In C we have the function y equal to e to power 3x minus e to power x divided by 2. Its derivative is 3 times e to power 3x minus e to power x divided by 2. Just this number 3 came out from there. Okay, we can take the equation and we can substitute the derivative there and the function here, and we will get the derivative in the left hand side, and then 3 times y is 3 times e to power 3x minus 3 times e to power x divided by 2. And then we have left this e to power x. Okay, how does it seem now? These terms will cancel out, and maybe we multiply both sides by 2, we would get minus e to power x is equal to minus 3 e to power x plus e to power x. Okay, I had a mistake here. Here was just e to power x. So here this number 2 was extra. So when I multiply with 2, I will get this one. And this is true. Minus 1 is equal to minus 3 plus 2. The equation is okay. In D, the function was 1 over 1 minus x. Its derivative we can calculate in many ways. Well, maybe it is best to write the function again in this way. Now the power 1 minus 1 will drop there. When we differentiate, we'll get minus 1 times 1 minus x. The power will be 1 less, it will be minus 2 times the derivative of the inner function. Well, this is minus 1. The minus 1s will cancel out. So we just get 1 over 1 minus x squared. This is the same as y squared. So our equation is okay. In E we had the function e to power x squared divided by 2. Its derivative is derivative of the exponential is itself, and we need to multiply by the derivative of the inner function. Well, this is 2x divided by 2, which is just x. So derivative of y is x times e to power x squared over 2. Now we can recognize that what is this function here based on the task we were given. It is equal to y. So we get that the equation y prime equal to x times y is true. That was the task. In F, our function is 4 times ln of x. The derivative of 4 is 0. The derivative of ln x is 1 over x. So the derivative of y is this. Now we should check the equation x times derivative of y is 1. Well, let's substitute the derivative of y. X times 1 over x is 1. In the left hand side the x's cancel out and give 1. The equation is satisfied. In G, our function is 3 minus x plus x ln of x. Let's differentiate. Derivative of 3 is 0. Derivative of minus x is minus 1. Then by the product rule, derivative of x is 1. Derivative of ln x is 1 over x. Here x's cancel out, so this is just 1. 1's cancel out, and we get that the derivative of y is just ln of x. So these things are equal. So the equation is true. In H we had that the function y was e to power x plus sine of x divided by 2 minus cosine of x divided by 2. Let's differentiate. Derivative of e to power x is e to power x. Derivative of sine is cosine. Derivative of minus cosine is sine. And let's substitute these things to the equation. Let's substitute this to derivative of y and this one in place of y. We should see that this is true. Well, e to power x is in the both sides. Sine of x over 2 is in the both sides. And if we calculate now the right hand side, it would be just cosine x divided by 2. And the left hand side and the right hand side are the same, so the equation is okay. Last in this exercise we have the function pi times e to power minus cosine of x. The pi is just a constant, so it can stay there. Derivative of the exponential function is itself times the derivative of the inner function. Derivative of cosine is minus sine. The minus signs cancel out and we get just sine. So the derivative is pi times e to power minus cosine of x times sine of x. Now we can recognize that this function here is y. So the derivative of y is y times sine of x. That was the thing we were supposed to show. It is true.